everyone. So let's discuss the last three questions of May June 970931 paper. So I have done this previous questions in last two videos. So this is in the continuation of that. So here's the question number 7. Let fx be cos x upon 1 plus sin x. Show that f dash x is less than 0 for all x in the interval minus pi by 2 to 3 pi by 2, and it means that we can see it start from here not including this line. It means sine will not be minus 1 because sine is 1 here, 0 here, minus 1 here. So minus sine is not going to be minus 1. So let's find the, and we can see it is fx is ux upon vx type. So we are going to use the quotient rule in this in order to find the f dash x. So f dash x is equal to, and I'll tell you the best way to remember it. You start with the denominator. So denominator square, the differentiation is denominator square, and write the denominator as it is. Do the differentiation of numerator, that is minus sin x, and minus this time numerator as it is cos x, and do the differentiation of denominator, it is 1 plus sin x, and it would be 0 and it would be cos x. So we got it as cos x only. So we can simplify it more and we can write it as minus sin x minus sin square x minus cos square x and whole upon 1 plus sin x whole square. And we can see there is the sin square x and cos square x, and there is a minus both the places. So we can use, since sin square x plus cos square x is equal to 1, this is equal to 1, so we can rewrite it as minus sin x minus 1 over 1 plus sin x whole square. Now I'll take minus common from the numerator. I'll get it as 1 plus sin x. I'm rewriting it. It was supposed to be written like sin x plus 1, but I have written in the 1 plus sin x form. A whole upon 1 plus sin x whole square, and then this will be cancelled, 1 power, and we left with minus 1 upon 1 plus sin x. And here, since sin x cannot be minus 1, so we can say from here that 1 plus sin x is always going to be greater than 0 any which way, because we know that sin x is in between minus 1 to 1, and if you are adding 1 then it would be automatically greater than 0 because it is not including minus 1, otherwise it would have been 0. So it means f dash x is less than 0. That's the question. I hope it is okay. Let's do the B part of it. So here's the B part. Find the integration of fx dx, and fx from here it is cos x upon 1 plus sin x from pi by 6 to pi by 2. Give your answer in simplified exact form. So we can see the differentiation of ddx of 1 plus sin x is actually the cos x, and hence this is of the form integration of, we can write g dash x upon gx dx, and hence it is log of or ln gx. So we'll use this, and it is, we can write it as ln modulus 1 plus sin x, and we can remove the modulus because we know that it is never going to be less than 0. From this is equal to, actually I'll write like this, and it is equal to pi by 6 to pi by 2. This is the integration, and this is the explanation how it is of this form, and hence it is ln 1 plus sin pi by 2 is 1 minus ln 1 plus pi by 6 is 1 by 2, so plus 1 by 2, and it is ln 2 minus ln 3 by 2. And now we'll use the log property, that if there is a minus b, log a minus log b, then it would be log a upon v, and hence it is ln 2 upon 3 upon 2, and that is this will be in the multiplication, and hence we got ln 4 by 3. That is the final answer. I hope it is clear. Let's do the next question. So here's the question number 8. A certain curve is such that its gradient at point xy is proportional to. So gradient, we know gradient is dy over dx, so we'll write one by one the condition. Proportional to, so proportional to y over x root x. Okay, the curve passes through the point with the coordinates 1 1 and 4 e. So by setting up and solving a differential equation, find the equation of the curve expressing y in terms of x. So we'll do one by one every step. Dy over dx is proportional to, it means this proportionality sign will go with the is equal to k. There is a constant, proportionality constant, let's say k, y over x root x. And from here we can form, this is the differential equation, and then we'll solve it by making it as dy is equal to ky over x root x dx, or we can translate this over here, then it becomes dy over y integration, and now integration k is a constant, so I'll take it outside, and dx upon x root x is actually x into x to the power 1 by 2, and that is x raised to the power 3 by 2, and hence it is x raised to the power 3 by 2 in the denominator, or I can transfer it to the numerator. It will become x raised to the power minus 3 by 2 and dx. Now integrating both the side, we'll get ln y is equal to k times x to the power minus 3 by 2 plus 1, minus 3 by 2 plus 1 is minus 1 by 2, and hence upon minus 1 by 2 plus a constant c. So we can rewrite also, let's rewrite it again. Ln y is equal to this minus 2 and x to the power minus 1 by 2 is upon x to the power 1 by 2, and hence it is root x plus c. So now we'll use these 2 points which lie on the graph. So at 1 1 y is 1, so ln 1 is 0 is equal to x is also 1, so you got minus 2 plus c, minus 2, oh I forgot the k, so sorry, it is minus 2k, and hence we got c is equal to 2 times k. It is equation number 1. And at 4e it is ln e is equal to, and we know that it is ln means log base e, so it is base and value same, so it is going to be 1 is equal to minus 2k over root 4 is 2 plus c. This will give c is equal to 1 plus k. It is equation number 2. So from 1 and 2 we can see 2k is equal to 1 plus k, or we can write directly that k is equal to 1. If k is equal to 1, c is equal to 2, and hence this will give y value as, ln y, not y, ln y is equal to minus 2 over root x plus 2, and we know we'll use the property of log, basic definition. This ln means base e, so y will get from here, y is equal to e raised to the power the whole thing to the other side, 2 over root x plus 2. That is the final answer in the terms of y in terms of x. I hope it is clear. So let's do the next question. Here's the next part of it, B part. What happens to y as x tends to infinity? So we'll write it again. Y is equal to e raised to the power minus 2 over root x plus 2. So let's find out. If x tends to infinity, root x tends to infinity, and hence 1 upon root x tends to 0, and hence we can say that minus 2 upon root x tends to 0. So y tends to e raised to the power 0 plus 2, that is e raised to the power 2. So y tends to e raised to the power 2. I hope it is clear. It was of 1 mark, so you could have written directly by including this thing, that x tends to infinity minus 2 over root x tends to 0. I hope it is clear. Let's do the next part, next questions actually. Here's the question number 9. With respect to the origin, the vertices of a triangle ABC have position vector OA, OB, OC as this. Use a scalar product, show that the angle ABC is a right angle triangle. So it's not compulsory, but I'll draw it and then it would be clear more. Suppose this is A, B, C, and there is somewhere origin, so it is OA. No need to mark it as A vector because it's given OA vector. This is OB vector and this is OC vector. So if we are going to prove that this angle is 90 degree, first of all we'll find angle vector BA and vector BC. And by the property of scalar dot product, if their dot product is 0, it means they are perpendicular, right? So first of all we require to find BA vector. BA vector is OA vector minus OB vector, and we'll get it from here. OA is 2i plus 5k, and minus OB, that is minus I cap minus 2j cap and plus 2k cap. This is the BA vector, and in the same way BC vector will be OC vector minus OB vector, and that is we'll get it from here 1 1 1 minus 3 2 3, and that is minus 2 I cap minus 1 j cap minus 2 k cap. Now we have BC vector both. So first of all we'll find BA dot BC vector, and then we'll check, and we know that this is going to be minus 1 into minus 2 plus minus 2 into minus 1. I could have written it directly, but I'm writing like this, 2 into minus 2, and hence it is 2 plus 2 minus 4, and hence it is 0. So since BA dot BC is equal to 0, the angle between them means angle ABC is 90 degree. So I hope it is clear. This was quite easy, you can see. Let's do the next part of it. Show that the triangle ABC is isosceles. So if we know, first of all, in a right angle triangle, if you have a right angle triangle, then only these two sides can be equal. Otherwise you cannot include the hypotenuse in this in order to prove that this is isosceles triangle. And we see if the diagram, it is BA and it is BC vector. So we have the BA vector, and BA vector we have, what was that? It was, just a minute, I'll copy it from there. It was minus I cap minus 2j cap plus 2k cap. And in the for BC vector was minus 2I cap minus j cap and minus 2k cap. So if we want to prove that ABC is isosceles triangle, we'll prove that if AB distance, that is magnitude of AB vector, is equal to magnitude of BC vector, then it is proved. and hence we'll find BA vector. Magnitude of BA vector, sorry, magnitude of BA vector is square root of 1 square 1 plus 2 square 4 plus 2 square 4, it is root 9, and hence it is 3. Again vector BC magnitude is square root 2 square, that is 4 plus 1 square means minus 1 square 1, and again minus 2 square 4, it is again root 9, it is 3, and hence we can say that ABC, triangle ABC is isosceles. I hope it is clear. So let's do the next part of it. In this part, find the exact length of the perpendicular from O to origin to the line through B and C. So it is like that. O is here and B is, let's say, here, and C is somewhere here, and A was somewhere here. Now I want to find the exact length of the perpendicular from the origin to this. So first of all, we'll find the equation of line passing through B and C. So we require two things for an equation of line, that is A and B vector. A is a point on the vector, point on the line. So here A can be taken as OB vector, that is, it is given, and let me copy it from there. It is 3 I cap plus 2 j cap plus 3 k cap. We'll take this, or we could have taken the C as well, or we can take C, but I'll take B. I have started with B, so I'll take the B only. And B vector means a vector in this direction, so why we need to find any other vector? We have the BC vector, so B vector can work as BC vector, and BC vector was minus 2 I cap minus j cap minus 2 k cap. So the equation of line through B and C is given by R is equal to 3 I cap plus 2 j cap plus 3 k cap plus lambda times, lambda is any scalar, lambda times minus 2 I cap minus j cap minus 2 k cap. So now we'll mark this point as P, so equation, you can say coordinate or vector OP, we can take OP in any, P is any general point, any random point on the BC, so any point on the BC line through BC can be taken as 3 minus 2 lambda I cap plus 2 minus lambda j cap plus 3 minus 2 lambda k cap. Now we have OP and we have the line through B and C, and we can see that these two should be perpendicular. So OP and BC, line through B and C should be perpendicular, or we can say the direction vector to the line through B and C should be perpendicular to OP. So now we can write OP dot product with this minus 2I minus j minus 2k cap should be 0 because they are perpendicular, and hence OP and this dot product will be 3 minus 2 lambda times minus 2 plus 2 minus lambda times minus 1 plus 3 minus 2 lambda times minus 2, and that should be 0. So let's simplify. It is minus 6 plus 4 lambda plus minus 2 plus lambda minus 6 plus 4 lambda is equal to 0. So here it is 4 lambda, 4 lambda, that is 9 lambda is equal to minus 6 minus 2 minus 8 minus 6 minus 14. So it is minus 14. To the other side it will become plus 14. So lambda we got it as 14/9. As soon as we got lambda, we can put it here to find the OP vector, and this will give you OP vector as 3 minus 2 times, so it is 28/9 I cap plus 2 minus 14/9 j cap plus 3 minus 2, so it is 3 minus 28/9 k cap, which can be simplified as minus 1/9 I cap, and 9 2s are 18 minus 4 plus 4/9 j cap plus again minus 1/9 k cap. So this is the OP vector. So in order to find the exact length of the OP vector, we'll find magnitude of vector OP. So OP vector magnitude is going to be square root of their coefficients. So minus 1/9 square, minus 1/9 square is 1/81, plus 4 square by 9 square, that is 16/81, plus again 1/81. So we got it as square root of 18/81. So 18 is 9 into 2, so 3/81 square root is 9, so 3, and this is root is 2. So the answer is 1/3 root 2. That is the length of perpendicular from the origin to the line passing through B and C. I guess it is okay. Here's the question number 10, and the last question of this paper. The complex number u is given by this, where a is real. Express u in the Cartesian form x plus iota y. Now where x and y are in terms of a, of course, so we know it is in the fractional form, so we will multiply by its conjugate to transform it in this form. X, that is a here, a plus 2 iota. I'll multiply in the numerator and denominator by a minus 2 iota upon a minus 2 iota. So we got it as 3 iota into a minus 2 iota over, it is a minus b, a plus b, so a square minus b square minus 2 iota whole square. Now we know that iota square is minus 1, so we'll use this here and we'll get 3a iota minus 3 to the 6, and iota into iota is iota square, that is minus 1, so it becomes plus 6 over a square is a square, and 2 square is 4, and iota square is minus 1, so it will become plus 4, and hence we can separate it. It is like 6 over a square plus 4 and plus times 3a over a square plus 4 iota, and that is the form. And here this can be x and this is the y, we can write, but it is fine if you leave it here. So let's do the next part. Next part is find the exact value for which argument of u star means this is the conjugate of u, and here u is complex number u is given as 6 over a square plus 4 plus 3a over a square plus 4 iota, and hence the u star we can find it is going to be 6 over a square plus 4 minus 3a over a square plus 4 iota. Now we have a star, and it's given that argument is 1 over 3 pi, and that means tangent inverse of this, that is minus y over x, so 3a upon a square plus 4 upon 6 over a square plus 4, it is given as pi over 3, so we can it is minus here, and hence we can say it is minus 3a over 6 is equal to tangent of pi by 3, and tan pi by 3 is root 3, and hence we can cancel it 2. So a is equal to minus 2 root 3. So this is the exact value of a. If they have asked for exact value, we are not going to solve for root 3, otherwise it is not exact value, you will get the approximate value, because root 3 is an irrational number. So let's do the next part of it. Here is the b part first. So on a sketch of an Argand diagram, shade the region whose point represent the complex number z satisfying this inequality and this inequality. From here we can see it is the perpendicular bisector. Perpendicular, we can rewrite it as z. I'll write it here so that I can draw it here. Now z minus 2 iota, and this is z minus 1 plus iota, and this is the perpendicular bisector joining the point. This point represent on the Argand diagram as 0, 2, and this point on the Argand diagram is 1, 1. So join perpendicular bisector of line joining 0, 2 and 1, 1, and since it is less than, so it will go through will shade this area where it is less than. The distance of the points from the 0, 2 is lesser than the distance of the point from the 1, 1. And this is a circle. Of course we can see here the center is 2, 1. We can see it from here, z minus 2 plus 1, so 2, 1, and radius is 2. So I'll draw it. Let me draw it. So here I have drawn it. This is Argand diagram. This is the real axis. This is real axis, and this is the imaginary axis. So I mark the point 0, 2 here, and 1, 1, and this is a perpendicular. This line is a perpendicular bisector of the line joining these 2 points, and another circle is with center 2, 1, and the radius is 2. So we need to shade this. So I'll shade it with, and we can see this is less than this, so we'll shade this region here. And when we are going to shade the another part of the for the circle, it is less than 2, less than or equal to 2 means that it will include the region inside it. So we can say directly at the last what is going to be the required shaded region. This is the intersection of these two, and that is going to be the part inside it. This is going to be this should be the shaded region, required region, including the line and the circle. So I guess it is okay. Let's do the next part of it. The second part is, calculate the least value of argument z for points in this region. So least value, we know it is being measured from the initial line, that is this line, x-axis, real axis. So the first value we can get, the least value of the argument we'll get at this point. So we'll join a line from this point to this. Now we can see the perpendicular and base in it. Perpendicular and base, it's like this. So this distance is 2, this distance is 3, because this point is actually 2, 3. So the point which is for which we are going to find the argument is going to be 2, 3. So for 2, 3, what is this angle? We can see it is the, let's say it is theta, then tan theta is 3 by 2, or we can say theta is equal to tangent inverse of 3 by 2. And in order to find this point, we can use the another geometry also, like equation of perpendicular bisector, and then where it intersect the circle, then also we can get the value of 2 by 2 comma 3, this point. And we'll calculate the value of this, and it is actually theta is equal to tan inverse 3 by 2. It is 56.309, so 56.3 degree, or we can calculate in the radian also. So I hope it is clear. So that was the last part of this last question of this paper. I hope it was helpful. Thank you for watching. Thank you so much.